Hello, this is Christophe de Dinchin, and I'm going to give you an update about DB48X, my implementation of RPL for Swiss Micro's DM32 and DM42 calculators. So this is about version 0.7.5, which I released yesterday, and I'm going to cover releases 0.7.4 and 0.7.3 since the last update I did was about 0.7.2. So you see a Swiss Micro's DM32 here running that software, and it also runs on an older model from Swiss Micros called the DM42, which you see here. So it's just exactly the same software. So I'm going to use it on a DM32 for today. You have seen demos on both on this channel. A quick reminder that RPL is an RP, so reverse polish system, where you enter operations first and then do the computations. And it's calculators, so you can type commands immediate like this. It has a built-in help system that you can access by holding a key. And because it's RPL, you can enter stuff with alpha mode. I'm going to type here the first letters of the version command, VERS. Then I'm going to use the built-in catalog. You see it, you could access it at any time with Shift and plus, but because I'm in alpha mode, just hitting plus is sufficient. That's an auto-completion catalog. So if I hit F1 there, sorry, F6, I'm going to have the version number and then a list of all the features in the calculators that shows here. If I now type alphabetic mode AB, you see anything that contains AB, so for instance, ABS, and I get an error because ABS doesn't apply to the text that is on the stack. Now, earlier versions of DB48X required you to clear errors explicitly. That was not consistent with the way HP calculators do it, so now you don't need to hit the exit or backspace key. You can simply type ahead and the error is cleared automatically. So now let me see what kind of new features we have, and we'll start with something simple, which is sums and products. They are found at multiple places, but one of them is in the numbers menu, which is second shift num. So you may remember from earlier demos, one shift, two shifts. And so here I'm going to enter an algebraic expression. That's this key here with the parentheses and the tick. The first tick enters, the first hit of this key enters the ticks. That's the separator for algebraic expressions if you don't want to calculate in RPL reverse polish notation. Then I hit the sum here. And in order to enter alpha, I used Shift Enter before. I can also hold the left arrow key and quickly hit another key. I have to be quick, otherwise I will get the arrow effect. It's going to scroll, but if I do that quickly, so see, I did not do it quickly enough. So that's because I usually use two keys for that, in which case it's really convenient. And then, so I entered the I here. That's the name of the variable I'm going to sum on. Then I separate with this. Because I'm inside parentheses, it's going to insert this semicolon. That's the separator for arguments. I'm going to do a sum from 1 to 100. And I'm going to do a sum of I squared. So Shift C gives me a square. If I hit enter now, I have a graphical rendering of that expression, and I can now evaluate it like this. Now, if instead of a sum, I want a product, I can use the history. So I'm going to hit twice on Shift and see the history here. And that's the history of editing. It's 8 levels deep. And I'm going to replace this sum with a product. Now it inserts the parentheses. I don't want them, so I'm going to remove them here. And now I have this product. Now this product takes a little longer to compute because DB48X does an exact computation in that case with all the digits. And you see it's a fairly large number. So it has this dot, dot, dot in the middle, indicating I can't see it. So two ways to see it. I can put it in the editor, and then I can scroll horizontally. That's good if you want to modify it or do something like that. But in my case, if I just want to see it, I can use the show feature, which is shift dot, and it's going to convert it to a graphical mode form. I can scroll like this. Now, if I go back to my, oops, I divided. I go back to my history there. And by the way, you notice that it shows me the history of stuff that I did not enter, but I quit. So I can use show here to see the graphical form of any object on the stack as well. Which brings me to something that is relatively new as well, where I can take any object, so that object for instance, and now I can go to the graphics menu and convert it to a graphic object, Rob. So what you see now is a slightly different thing. It has this outline around it, and the outline indicates that I'm actually watching a graphic object. If I do a show now, that's the graphical rendering of my object, but that's really, now it's no longer a mathematical object, it's a bitmap. Now, in order to see the difference, I can, for instance, decide to switch the display mode, and I'm going to go to the UI menu for that, and say that I don't want a graphical, oops, sorry, that I don't want a graphical result, but a text result. And it's the same thing if I edit it, I'm going to see that it's really a graphical object. Now, one interesting variant of that is that I can recall bitmap files. So let me use the text that you see here. So shift twice, enter. And then I'm going to type, so bear with me because I'm a bit slow since I'm behind the camera there, of IMG. Now shift divide, no, shift divide. And then I want for 1 C, why is it B dot B, believe it or not, I practiced that, BMP. Okay, now I go to the memory menu and I use the recall function. Path not found. Huh. Ah, yes. I need this. And now I have this nice graphic, and I can do dot and see my off image on screen. So you can also store it under a different name. So store and recall now support bitmap file. They already supported CSV file. They already supported source file for any kind of object, binary file, etc. So refer to the documentation to see what you can do with store and recall to access the built-in fat partition. So we saw sum and products. We have another set of functions which are fairly basic, and they're under proba. So you may remember we had the gamma function and things like that here. So we have combinations now and permutations. So fairly standard old functions. Nothing really fancy here. What is more interesting is that you now have user-defined functions, and because I did a failed run before, I need to clear this variable first. Bear with me for one moment. Let me purge that. So let me enter an expression in which I put the name f, and then I hit the same key again. Now this gives me parentheses because I'm inside an expression. And then 1 space 2 space 3. Then you see that the space smartly inserts semicolons because I'm inside an expression, inside parentheses. And now I have a user-defined function call here. So if I try to evaluate that, what it's going to do is try to call a function f with parameters 1, 2, 3, and because f is not defined, it does nothing. Now, let me define f. So let me create a small program here. Sorry, get there. So I multiply the bottom 2 arguments on the stack and then add what remains. And let me store that in f. So now if I evaluate f1, 2, 3, I get 7. That's 6, 2 times 3 plus 1. So user-defined functions, very useful for many things. We also have rounding and truncating errors. So you can find them, for instance, in the real menu. And if you take the parts, sorry, it's in the parts menu. Here, so you have round and truck. So if I do 1, 2, 3, 6, 8, 5, and I take this and I truncate it to 3 digits. That's 3, 6, 8. If I round it to 6 digits, to 3 digits, I get 3, 6, 9. Now, part of the problem with the definition of these functions in RPL is that it uses the hard-coded value 12, which is the number of digits, as a limit for switching between two behaviors. Now, you may recall that the DB48X implementation has variable-sized floating point. The default precision is 24. So when you see 24 in the user manual for the HP48, when you see 12 as the limit for rounding or truncating, you have to replace it in that case with 24. And any value above it will do as well. Let me, as a reminder, in case you don't recall what variable precision means, so let me do, for instance, let me switch to radians. And you may know that the arctangent, so let me do that in degrees first. Oops. So in degrees, the arctangent of 1 is 45 degrees. Now, if I do that in radians, that turns to be 1/4 of pi. And I can now multiply this by 4, and I have a relatively good approximation of pi that I actually computed. It's exact to the number of digits I have here. Now, if I go to my disk menu, and now I say I want 160 digits of precision, and I want 160 digits shown, say. So you see that here I don't have 160 digits because I did the computation with 24 earlier. So let me do the same computation again, arctangent of 1 times 4, and now I have pi with 160 digits. Let me go back to 24 digits for speed and memory, and you see that my number is still kept with all the digits because it was computed that way. So you can adjust the computation precision along the way you need. As far as I know, that's the only calculator that does that today. Another interesting change that happened, so that's more in the UI interface, is for editing programs. So you may remember if you hit the var key, what you get is the list of variables in the current directory. And you have, with shift once or twice, you have 3 features for each variable. Either you evaluate it. So here I'm evaluating this beep test program that just runs a number of beeps. If I hit shift, then I'm going to recall the content. So let me recall the content of my F program that I had before. And I can, for instance, replace that content with two keys, two shifts, and then that's the arrow is on the left of F, meaning it's going to store into F. And now if I evaluate F, I get 1, 2, 3 instead. So back to my BIP, if I recall BIP, and if I edit it with this key, so you see that now I have this relatively long line, and this may actually be a bit too long for my taste. So in the user interface menu, so I go back to the UI menu here, and there is now this editor wrap, which is set to 40. The actual default is 20. So let me go to editor wrap here. And if I edit this, you see that now my long line has been truncated, which may make it easier to see smaller chunks of code. I can shift that to 10 and you'll see the effect again. So now my lines are even shorter. So that lets me tweak how wide I want this. So let me get back to the default, which is 10. And I can also change the tab width. So for instance, if I want a tab width of 10, if I edit this, you'll see that it's a number of pixels. So you see that now the indentation is smaller. If I put a tab width of 160, and if I edit this, now I have very, very wide tabs. So let me get back to a reasonable default for tabs and edge wrap. Now, if you're used to RPN calculators have a vertical display of programs. So if you want to be, if you're more familiar with this way of doing things, you can enable vprog. The actual name of the function is vertical program rendering. In that case, it essentially tries to put only one instruction per line. So if you're more familiar with the way RPN calculators do it, you might prefer this one. I personally don't use it, but this is a request. So this is for the text editor. And we have also all the missing RPN commands are now there. So the RPN stack commands, sorry. So what I mean with this is that we have things like ndup n, pick3, nip. So the nip command is here. So I think that in terms of stack manipulation, DB48X is now feature complete with respect to the HP50. We also have operations that act on memory with an operation with it. So store plus, store minus, store times, and store divide, as well as recall plus, recall minus, recall times, recall divide. So let's try this with my variable f, which now is 123. So back menu, shift this key, gives me the previous menu. And I'm going to, for instance, add or multiply this. No, well, I'm going to add 25 to f. Sorry. So store plus, and if I now look at f, I have 125 added. So the recall, add, recall, the recall operations do not exist on traditional RPL calculators, but they are inherited from DM42, and some RPN calculators that had these features. And they are also found, for instance, in C47A and WP43, which are other firmwares for these calculators. And you have the increment and decrement features. So work like on RPL, nothing really complicated here. Okay, another minor change, but it's really convenient when you actually enter these kind of numbers often, is so you have this complex menu. You can do complex operations. You may recall, so for instance, I can add 3 plus 4i and multiply this by 3 plus, oops, 7i and multiply the two numbers, and I get this operation. I have polar number representation that can exist simultaneously with, oh, I need to be in degree for that to be shown. So it's easier if I'm in degrees for this kind of thing. So complex, 12 and 30 degrees. And then I can, for instance, add the two, and it's going to do the operation in such a way that you end up with the converted value. Now, one thing that was changed is that you can now enter partial numbers, like 36i, for instance. That works, and you can also enter I25. So if you have imaginary only numbers, they can be entered more quickly. Now, let me get to another interesting change is if you have an expression, so let's say, for instance, I have x, and let me take the square root of this and invert. And you may remember the magic menu. The magic menu, the tool menu here, brings me something that depends on what I'm doing. So right now I'm editing, so it's bringing the editor menu. And if I enter the value, and then I hit this, I get what applies for real numbers. With expressions, it was not doing a very good job, so now it's actually going to a menu that deals with expressions. Now, this menu contains something that is new, above the F4 key, that's the poly. And that's one of the major additions to 0.7.5. It's support for polynomials. So let me give you an example of this. Let me take x minus 3, and I'm going to do that to the power 3, and I convert that to a polynomial. And now it's expanding the polynomial. Now it looks the same as before, but if I edit it, you see that I have poly at the beginning. And if I try to put something in there that is not polynomial, like for instance, plus sine of x, then it's going to reject it, because it really expects a polynomial here. Now, what is the benefit of having a polynomial? Is that you can do operations on x, like for instance, you can divide it by, so let me use the infamous pick 3 that we mentioned before, and I'm going to have pick 3 here, and I divide, and you see that it does Euclidean polynomial division. And if I had something that is not exact, so let's do it with x minus 4, for instance. Now I'm going to do a divide here. And so I have this value, but I also have in that case a reminder, which I'm going to see with, so if I do, where is the magic menu here? So, sorry, I want polynomial for that. I thought that the reminder was here. Okay, so let me pick up the reminder from another menu for now. I'm going to use reminder here. So now I have a non-zero reminder as well, and I can have a polynomial reminder as well. So real operations on polynomials, which the HP48 does not have, and the HP50 implements in a way that is not super convenient. in the way you have to have dedicated functions like div2 for that. So by adding a polynomial type, you can use the same usual features, but apply them to a polynomial and expect them to work transparently, sticking with polynomials that way. And you can actually expand polynomials, for instance, to a given power, to things like that. So now, one thing about expressions that let me undo that. So is this one? By the way, when you have a polynomial, you get a slightly different menu. You get the polynomial menu, and that polynomial menu has an option to display a prefix in front of polynomials to distinguish them from regular expressions. Okay, so I can convert a polynomial back to an equation like this. So one thing that is also interesting about expressions, you may remember they have a graphical form. So if I do x, and I had the example where I took the square root and add 1, for instance, and let me take the exponential of this thing. Now the cycle function for that, so you may remember what cycle does. Cycle is a quick way to have alternate forms for something. So for instance, and it's bound on EX. And so for instance, it cycles between the fractional or decimal form of a number. And for complex numbers, it lets me cycle between polar and rectangular. Two examples of the cycle function. Now, when you apply cycle on an expression like this, what it does is that it changes whether you want to display it as text or graphically. And so you see you have 4 modes where you have the result, the last level of the stack, level 1, and the rest of the stack being shown graphically. So cycle is going to cycle between the 4 modes. I think that's about it for what is new in the last 3 minor releases. So you see, well, it's not all of it. There is plenty of other minor things. Like for instance, if you go to the characters menu, you now have things like music symbols, and you have a better way to enter RPL programs. So RPL constants you can enter directly, for instance, the constant E. If you really want to do it manually, you can enter it like this. And you see that it's a constant because it's in bold, as opposed to having, for instance, the name E. So if I enter the name E in lowercase, you see that it displays in italics and without bold. If I evaluate that, I get nothing. If I convert it to a number, it's going to fail. Oops. If I convert it to a number, it doesn't find a value. But if I convert the constant E to a number, then it finds the value for that constant. So many minor things like this and bug fixes, I refer you to the changelog and the release notes. But I think we covered most of the big things. So most important in terms of future work is the changes related to polynomials, because that will let me do a better work with the CAS function, the computer algebra system functions. The collect and expand at the moment are not working very well. They are going to work much better in future releases thanks to these changes. And we are going to be able to support a lot of interesting stuff in the algebra menu. By the way, an incompatibility with HP calculators has been suppressed. The rewrite function has been rewritten as match up and match down, and takes the arguments the way the HP calculators do. So you can now, for instance, match up and match down an expression with a test, for instance, on the condition regarding the match. So you can say, I only test if this condition is true. I need to add this to the demo file. It's not there yet, but that's some of the changes. Okay, I think that's about it for today. I'm lucky I did not run into any major bug, I think, while I was doing this demo. So things went smoothly. I hope you give it a whirl, and please give me feedback and post what you find either on YouTube or find issues on the GitHub project. Thanks a lot for listening, and let's keep hacking and improving this software.